Right. Okay, thank you guys. Thank you for showing up. So firstly, I'm gonna go over the Duke Compute Cluster documentation. This is already available on the course website. But before we start, in a few words, what is Duke Compute Cluster? It's just a high performance compute resource for us that's available to us. It basically means that we have access to a bunch of GPUs and a bunch of CPUs, and then we can submit jobs to this cluster, and then using some uh, like we're gonna talk about this later, but like basically the cluster figures out what the most efficient resource allocation is to get your job done. So it allows a lot of users to share hardware essentially. So Duke Compute Cluster is Duke's version of a HPC or a high performance compute cluster. But the same sort of principles are going to apply to any HPC that you come across in your career. So as we go into like our careers, if we are making models that deal with big data or use GPU, chances are we are going to have to use a some sort of HPC, right? So getting familiar with the DCC, a lot of the skills you'll see is very transferable. Okay, let's get started. Uh, so in Duke Compute Cluster, we have all the courses running this year uh, as a whole have about 1 TB of shared memory. And then when you make an account here, you're gonna get 25 GB of memory that's just for you. Uh, Ideally, try not to use your own space because it's not too much, but for the uh, demonstration purposes today, we're gonna be saving most of our stuffs in our own directory. Okay, so if anyone wants, you can just follow along. Uh, does anyone want to follow along? Interested? Okay.
So we set it up on our
Yeah. Yeah. So we can just have like an account ready to go, and it doesn't matter if you use it or not, but it's like pretty neat to like have it running. Let me know when you guys have like a terminal open. Okay.
Yeah.
So when you're ready, we can just go and copy the command from step 1.2. Replace your net ID, where it says your net ID on the brackets, with your personal net ID. So for me, it's RMR62. So what we're doing now is we're using a SSH protocol to get remote access to the Duke Compute cluster through our terminal. SSH is something that if you haven't seen, you're gonna see a whole lot of it if you're like trying to access like remote servers or remote computers. Okay, and then just press enter. This is gonna be your Duke password. And after you press your passcode, you can select Duo Push, which is option 1 for us. And then it should pop up on your Duo app. Just hit accept. Okay. Is everyone here? Okay. So as we can see on the screen, we have access to 2 partitions. So 2 folders. The first one is our own folder For me, I used 84% of this folder. If you use 100%, just a warning, everything's gonna stop working. I just did that a little like few minutes ago and had to like rush to fix it. And then the second one is courses 25. This is basically where all the courses that they're using the HPC cluster are gonna save their data and like work from the like this is gonna be our main working directory. We can see already 64% has been used. Still a lot of space left. So the first thing you want to do is copy the command in section 1.3 and just run it. So what that does is like if you guys know what shortcuts are, it just creates a shortcut to that course partition in your home directory. Since I already ran it once, I don't need to do it again, but let me know if that works. Good. Just copy section 1.3, there's a copy button, and then just paste it. Can I see? Yeah, you can just do ls hyphen a. Just type ls hyphen, let me show you. Ls, oh, hold on. Do that, and then after you do that, you should see the IDS 705 storage. Do you guys see IDS 705 storage? Yeah. So the ls command just lists whatever folders there are. Okay, and then the next step is we have to say we're gonna use Conda as our environment manager, right? So the next line, you guys are all familiar with Conda? Yeah. So the next line just gets like downloads mini Conda, which is like I think a smaller version of Conda, and then it's gonna download it to whatever directory you're currently at. Uh, so for demonstration purposes, we can just all install it in the directory you are in. But it's also a good idea, like if you're running something, if you're trying to train like or fine tune a large language model, for some example, of course, 25 gigabytes is not going to cut it. Maybe 500 gigabytes, about 400 something gigabytes that's left. That's also probably not going to cut it. But the courses partition is probably a better place for you to like install Conda if you're trying to like do something very big. Right. So typically, so after you install Conda, essentially all the packages that you're gonna install using Conda is gonna be saved for me like in the home directory, right? So as you can see, I have dot conda, right? This is where most of the packages that I install using conda is going to be saved. Since PyTorch and like some of the packages that I'm using for the demo is not too big, it uses about like 15 gigabytes, the plus 30, the 80, it shows 84% here, but like it should be around 50%. Yeah, you need to download Conda specifically for, yeah, because this is what you're doing right now is you're doing stuff on a remote computer, right? It is not your computer. Yeah, not local anymore. Yeah, exactly. Yeah, there are two lines. So if you just copy the two lines and run it, it will install Miniconda on your for your account.
We should just download it here itself.
Yeah, you can just download it here and just copy whatever is in 1.4 and run it. If in the future you run out of space, you can always delete this and reinstall all of this in like the bigger directory.
Got it.
Okay.
There seems to be a license.
And the bigger
agreement.
directory.
Yeah, just agree to it.
The asset of system.
Just keeps going.
Yeah,
Keep holding on to it.
There is a more there.
yeah.
Just
Um, So it should be down. Install it in contact specifically.
Yeah, after you're done installing, just do ls.a again. You should have miniconda3.conda.conda rc in the directory. Okay. Let me know if that when you guys get there. Yeah, it does take a second. So another advantage of using clusters, apart from GPU, is the RAM. So you have access to about 200 gigabytes of RAM, which is probably much higher than our personal computers. So even if you need RAM, you can run your job in the cluster.
Yeah, not well, just a five, thing, that's like five.
Yeah, it was
Like,
like,
it's
I think like for a lot of people, it doesn't want to do this now. How much time are you guys thinking? You guys also have content. Yeah, I have fun. I'm with the
So when I'm trying to enter my password,
Yeah.
it gives me this error where it says connection closed by. I want that. And that's when I enter like the correct path.
Does your password have like hyphens in between? Like,
Now,
is it auto-generated? Or you
Yeah,
just
it's
you just
auto-generated.
copy and pasting it, yeah?
well, the copy and paste didn't work. But when I type it in manually and, yeah, it gives me this.
It gave it the same error a couple of times?
Yeah.
That probably just means that it doesn't recognize your password. Was everyone else able to log in?
I think when I don't enter the correct password, it just prompts me again, like a
Okay.
person, then they'll just do that. But when I enter the correct password.
Do you have Duo set up?
Yeah. But it doesn't give me like the.
Okay, I see. I guess
Yeah.
and you could like closing it and closing the terminal and then trying again. I've seen that like if you have like hyphens in between like auto-generated passwords, then you have to also put that in.
I don't have the .conda or any of the other.
Okay, that's fine. Yeah, that's fine. We're gonna get there in the next step. Thank you. For your net ID, what are you using?
FX 41.
FX41. Okay. Yeah, I can't think of why it wouldn't let you in. Maybe I don't know. SSH should be installed properly. It's like pretty straightforward. Could try another terminal maybe. Unlike VS Code.
Oh,
Was everyone able to install?
So,
Okay, yeah. Yep.
1.4.
Huh?
Yeah.
Yeah, 1.4, yep.
And there is a question asking me whether I need to update my shares with, the automatically.
Yeah, you can say yes. What that's asking you basically, like, yeah, what environment is gonna like load into. So whenever you, I guess, sign into your account, is gonna load into the base environment. Yeah. See if you have mini Conda 3. Okay, perfect. Yeah, that's finished. Okay, should we move on to a 2? Then did you?
Yeah, it's fine. Yeah, I'll just follow on it.
Yeah, sorry about that. You can reach out to like the OIT people.
Oh.
Maybe it's error on their side because that's like very weird. Okay, so let's just copy 2.1 and paste it. For the name of the environment to stay consistent with the demo, let's just call it test. So you can call your environment whatever you want, but let's call it test now. For Python version, let's use 3.9 and then press enter.
Not found,
Exactly.
not found.
All right, you have to log out, close the terminal, and log back in. Just close the terminal and sign in again. That should do it. Yeah. Yeah, SSH backend. Yep.
No, the command I created.
Yeah, this command right here. Can I see yours?
I noticed they use, dot conda, dot conda.
Yeah.
I don't have any of it. I only have the.
Oh, okay. So I see what's happening here.
Yeah.
So you have to run the second line. This one?
Okay.
Yeah, your one didn't install.
Okay.
Because like the Conda RT and start point of how we're gonna get later, I think.
Oh.
And, yeah. But even then, stuff.
There.
It's because
Why?
above it said like, do you want to make this your default
I think
thing
we
or
should
something like
go
that?
for it.
I wasn't sure, so I put no for now, but that.
Mine is still program.
If you put yes, then it wouldn't have not wouldn't have come to this
Now I restarted the terminal, so. Could try to install again. And then maybe do that, but,
sure, just delete this. Let's see.
yeah.
Yeah, so when it says like the step 1.2, when it says yes, no, select yes. So that way,
I noticed, see now I said yes, but I think last time I just didn't confirm the location properly, and so now it's.
Oh.
Assuming it's like, yeah.
yeah, so if you selected yes, then like when you load it up this time, you would have seen like this base guy.
Yeah.
So it basically doesn't know where Conda is.
But, okay, I'm just saying, just downloaded it, okay.
You guys also take a little while
Yeah.
maybe Conda now.
Okay.
But the idea is absolutely you can run this at a.
Yeah, okay. Okay, sounds good.
Yeah.
I think we can check if you have here or not.
Yeah, yeah, definitely. Um,
Whether- It's more than enough.
We did one for these.
They are very, what to say, they reply very quick. Yeah.
The other solution would have been just to manually add conda to path.
Oh, okay.
Yeah.
Path drawing, yeah.
Are you?
Yeah, it's done.
Oh, okay, yeah. No worries, no worries. No, it's fine. Let's wait for a few more minutes. Okay, for those of you who've already installed the Conda environment, let's see if the Conda environment exists with this command, conda env list. And it should show you the Conda environments you have installed. We're interested in test. Yes, yeah. Did you find the test environment?
Yes.
Perfect. Yeah, you can go ahead and activate the test environment. What did you? Yeah, the name in yeah, there should be test. Yeah, so conda activate and then whatever the name of the environment is, right? Yeah. Still installing.
I just closed out and then we started to do the content.
Perfect.
We no need to activate the base environment.
No, there's a test. Yeah. So the concept of environment is like a lot of times when you're working on Python projects, the project depends on specific versions of like libraries, right? So whenever you're working with environments, all of those versions, like specific versions of libraries, you can stays recorded, and then it makes it easier to make a requirements file or a YAML file and transfer it to another person who wants to run your project. And they can just use the same Conda environment basically. And that ensures that dependencies and everything stays consistent.
But after this command, after enter, nothing.
Yeah. So after that appears, so after we type conda activate test, we should see that,
Oh,
yeah, we see it changes from base to test. Perfect. You know, Fan, you might have gotten that error because like a lot of us were trying to get in at the same time as well.
Looks like it's not able to come up.
Yeah, I received the error message before. It's fine.
I have test and non-activated, right?
Yep, conda activate test. It should say test in brackets. Right here.
Oh, fine.
Yeah, that shows that this basically shows the environment that you're currently in. Yeah, everything that you install gets into that environment. Perfect. All right. So the next step, since we're one of the things that the DCC allows us is to interact with it using Jupyter notebooks. So the next step is to install a package that allows that ipykernel. So this just lets you interact with Jupyter Notebook. Let's install that. Make sure that you're in the test environment. And then after you're in the test environment, you can just type conda install this command right here. Section 2.4. Let me know when that's done. When that's done installing, you can just run this command. Yeah, you can just copy it as is and run it. So let's dissect it a little bit. After you install the ipykernel package, you're now invoking Python and installing what can I say? Like a profile for you to use. And the name of that profile is going to be test. You can call it anything. After you're done, it should say installed kernel spec test in whatever directory. Okay, yeah, that's gonna take a minute. Yeah.
It's installed kernel stack test.
Perfect. Everyone here?
Mm.
All right, let's wait for a second. You can just click the link in 3.1. Next step. Okay. Uh, it says installed, right? Okay. So you can click on the link on in step 3.1. And then let's click on Jupyter Lab. The first time it might ask some extra things. How it gives me a quota limit warning. I hit 100% just like 15 minutes before the meeting and everything stopped working. So make sure you don't hit 100%. It's gonna give you a warning, but yeah. I was trying to get this uh this example working for you guys. But yeah, I'll just yeah, let's talk about it when we get there. Okay. All right. Do you guys see this page? So we don't need to do anything in environment setup. We can set that as is. Our partition's name is courses 25. Make sure you have courses 25 selected. Uh, so you have these many, actually, these are the partitions, these many options. If you want to use GPU, always select courses GPU. So I guess the two that apply to us is courses and courses GPU. If you select courses, you only get CPU. If you select courses GPU, then you get access to GPUs. Okay. Uh, so all of this is, we're just trying to get a Jupyter notebook running, right? So how many hours do we want this to run for? It's automatically is gonna start at 1, but you can go up to 168 hours. Yeah, it's a good way to like get access to resources and also not feel too alienated, right? You can work from like a notebook. Uh, and then the next thing you have to select is the number of CPUs. Max you can select is 40. Let's go with 20. Or yeah, let's go with 20 for now. So this is the number of CPU threads, right? Uh, okay. And then total memory, this is the RAM. Maximum that you can ask for is 208 gigabytes of RAM. Let's ask for 120 gigabytes of RAM. And then we need one GPU. I don't think we can select make it two. Maybe we can make it two. But let's just use one. I don't think we need to ask for two. And then this additional parameter, just type that in. Yeah, your email address. Yep. Yeah. This is the email where
Oh,
yeah, the email address will have like it's gonna you're gonna get all of the notifications for all the jobs that you run, all the containers that you spin up, and if for any reason your job gets like canceled by a super user, they're gonna like, tell you why as well. So yeah, that's what the email is for important. Yeah, no space. GRES equals to GPU 1.
what is it? Which
Storage.
storage drive?
Yeah.
So how does that work? Once you run out, you need to, do you get more every time?
No, you need to delete it. Yeah, you need to delete some stuff.
And then what about for like GPUs? Is there like some limit for?
No.
GPU or anything like that?
There's no. You just get like, so what we're doing on this page is we're just requesting these resources, right? And then when we press launch, we're gonna get added to a queue,
I see.
right? So maybe for you guys, just select 60 gigabytes of memory and 10 CPU threads so that we don't like overload the system. But essentially what we're doing is we're just adding our name to a queue and telling the system that, oh, look, give me one GPU, 120 RAM, and then this many threads. So everyone's here, right?
How do you know how many CPU threads or how many like CPU? We're able to say 10 to 60 or like 20 to 120. How did you know those numbers?
So it says the current max is 40 here. So I know the range is 0 to 40 for CPU threads. And then the memory current max is 208. So that's how I know. It just says what the maximum is. Yeah, just a sensible amount. Yeah. Or basically try to use like the least resources that will get the job done. Yeah.
And is that just through testing that you?
No, like if, for example, if I had a training job that required 80 gigabytes of RAM, right? I'd probably select 90. Like if I have a if I'm reading in a data set that's 80 gigabytes,
Yes.
right? And all of that needs to be saved in memory and processed in memory, then I probably need like somewhere like 100 gigabytes of RAM for the system. So, yeah. Yeah. After you're here, just click launch. Let's see what happens to the system if everyone clicks launch at the same time. That's fine, don't worry. It should say queued.
Yeah.
Session was successfully created and it's queued. So right now, whoever is first in queue is gonna get their resources and is gonna go down in merit order based on priority. Yeah, it will still run out because the wall time that you select, that's the amount of time it's gonna stay active for. So if usually you should get it like within a few minutes. But if you're not getting the resources, then just like increase the wall time a little bit. That way, it's just gonna stay active for longer. There was a input where it asked for wall time, right? Yeah,
That's the, I can use that.
yeah. After that, it's gonna get reallocated. You got it? Yeah, perfect. I'm still waiting.
Confirmation, you're good. Oh, they're connected to Jupiter. Just click on it.
There's not in it.
It should say that it's running here, and then there should be something here. Yeah, you can click on that. Yeah.
Whoa.
Okay, I guess I'm still queued.
Why? Oh, you click the later down.
Because he's a common user.
I guess that.
Please be patient. That's another important lesson.
How long did you learn that one?
I waited in the DMV for 6 hours yesterday, and
Oh my goodness.
I felt like for a walk-in appointment. Yeah. I went 4 minutes after they opened. Yeah. Yeah.
You,
I did that for my state ID. I went to at like, no, I didn't go at 6, I went at 7,
mhm.
and we got back home at like 11.
Still?
Yeah. Because if you're doing a walk-in, and like people with appointments always come in, they will always get priority before you. This is the same at the SFN office.
And I'm guessing the appointments are not available for like once a year.
Yeah, exactly.
Okay, I think I figured out what's going on. I think there's not enough resources to support all of us. So yeah, at the same time, because I'm still waiting in queue.
Oh.
Yeah.
Options, just anything you want.
Wait, let's wait for 1 minute. Oh, there you go. Patience. Okay, so from this step, it's like pretty much like a normal Jupyter notebook. Let's see. So for you guys, the instruction is to click on Jupyter Lab, right? Oh, right, we already did that. We already did this part. Yeah. Yeah, click test. Yeah, notebook, click test. And then it should pop up a untitled notebook for you guys, right? So let's say this is the untitled notebook.
After the session is done, can we still, like, our wall time is expired, can we still access what we?
Yeah. Yeah, all of that is gonna get saved wherever you save it. So if you save it in IDS 705, for example, I recommend making your own directory. So if it's for a team, call it the team's name. If it's for yourself, call it like just make it yours. Yeah. Yeah, absolutely. Okay. Uh, Can you guys see these files, by the way?
Only some of them. Ideas, not really, only the money.
Uh, which files do you see?
Idea 705, and then it's mini content 3, on demand, mini content.
Okay. Can you go to IDS 705 and then go into demo, and then you should see all of these files.
Yeah.
So we're just gonna go over a simple PyTorch demo. So click on the GPU demo file, double click on it, and it should open up like this. Select kernel, select test, test. Yeah. All right, so one thing you have to do now is to install the packages, required packages. So to install the required packages, do you guys still have the terminal open, by the way? Copy and paste 4.2 and run that. It's gonna install PyTorch and matplotlib. So here's a very important point, right? So if you're using GPUs, there's a good chance that we will encounter PyTorch. And when you're installing the PyTorch library, by default, the version that gets installed does not support GPUs. Very important. By default, the version that gets installed does not support GPUs. So based on the hardware you're on, you have to find what version of CUDA that hardware supports. For us, I found that to be 11.8. So see how specifically I'm installing PyTorch CUDA 11.8. This makes sure that the version of PyTorch that gets installed supports NVIDIA GPUs.
Which always.
For all of us, it's going to be 11.8. Yeah.
Based on.
Yeah, that's based on the cluster, yeah. But like when you guys go out in the real world, you can just ask like whoever is maintaining the cluster. So yeah, without this specific package, GPU wouldn't work. Okay, let's kind of go over the code as the package is installed. I'm not trying to teach you guys PyTorch, but remember the project, like I think homework 3, right? You guys did digit classification. This is kind of like a similar problem, but this uses like a neural network designed from scratch. You guys also designed it from scratch, but instead of classifying it if it's a 3 or not a 3, it tries to classify if it's a 0, 1, like all the digits, 0 to 9, right? So the first two lines is very like uh, classic. So if you're using PyTorch and you want to be sure that GPU is accessible for you, you can just run these lines of code, right? It just checks if the GPU is available. And if it is available, then it just assigns torch to that device. So it's going to be most likely you guys are going to get like a Tesla GPU. If not, it prints that it's using CPU. This is how the neural network is defined. There's like a couple of layers.
Okay.
What's that?
You just said we need to run this code
Yeah.
to check the GPU if it's
Yeah.
available.
So yeah. So after you install the packages, did you install the packages yet? Yeah. So after we install the packages, we're going to restart our kernel. So every time we install packages, we have to make sure to restart a kernel on Jupyter Notebook to make sure that Jupyter sees those updates. Yeah, this is just a simple neural network architecture with ReLU activation. input, output. Uh, we're using the cross entropy loss as our loss function. Stochastic gradient descent for optimizer. And yeah, we can, no need to go into detail, but like essentially doing forward passes, using batch size of 64. Every 100 batches, we're calling that a epoch. This is where we're doing the backward pass. You guys should be familiar with this from home assignment 3. One important thing, every time we're doing a forward pass, how PyTorch, like just because of the how it's made, every time we do a loop, we have to set all the gradients to 0, or else it just like carries forward from the previous loop and the weights don't update properly. So this is very important, optimizer.0 grad. But yeah, this is just an example, right? So no need to worry if you don't understand it uh, as thoroughly. Okay. Does anyone have any questions about this code? I can answer specific questions if you have it. It's like I try to make it as commented as possible, right? The main goal for us is to uh, use GPUs, and then you can decide on how you want to implement it, right? PyTorch is just one way. We're almost done.
Still, yeah.
Yeah, no, I'm saying like we're almost done. This demo, and then I'm gonna, yeah, just this notebook, and then the next step is to like how we can run jobs without using this interface. Like if you just want to submit jobs through the terminal. Yeah. And that part is going to be pretty much exactly the same no matter what HPC you use. We're going to be using this like structure framework file type known as SLURM. There you just like you select all the resources that you need, name your output folder, name your error folders and all that, and it just runs on its own time. And then it's much simpler, I guess. If you want, especially for longer jobs, right? If you want to run something for 2 days, right? Probably Jupyter Notebook is not going to cut it. Running this now. Uh, yeah, so after all the packages get installed, restart the kernel and then run the thing. Run the first cell. The second cell is just a copy. I don't know how it got here. Yeah, but in general, PyTorch is great if you want to like make your own architecture. It's like a really straightforward way to make your own architecture. Like compared to the code that you guys had to write in class, the function here is just literally 8 lines, and still you're able to make your own architecture, right? Neural network architecture.
Yeah,
What?
they
More
more
what?
hidden, like they screen.
Oh,
But I think before it, once it finishes, it like automatically exits out of it.
Yeah,
So you just gotta wait.
yes, okay.
yeah. Feel free to delete the libraries, sorry, not library, environments that we use today before starting your own projects. It's gonna free up some more space. And also feel free to uninstall Miniconda and install it in the courses partition. That's gonna give you more space, right? Your personal directory only has 25 gigabytes of space, like we spoke about before. And also be mindful of the resources that you request and also the space that you use in the courses 25 directory because it's shared amongst all the students.
Of course, 25, IDS 705 at this semester.
IDS 705 plus all other courses. Yeah. Yeah. So all courses being supported by, I'm guessing, all courses being supported by Duke. Because like I see 4 or 5 other like courses, some AIPI courses there as well.
Yeah.
So yeah. Okay, so when we get our code running, the first thing that we're looking at is it should say using GPU. Where is this coming from? It's coming from like these 4 lines. It's just checking if a GPU is available.
Oh, yeah, I have not. Yeah, I just sort of not. No, no, I'll have to take. No, no.
You can also run this command to see like the GPU resources that you have in your cluster. But I think you have to also install, like use sudo apt install to install this first. So like if you are like trying to figure out what CUDA version you need, right? Like 11.8, this is how I found it initially. This tells you what CUDA version. Okay. Uh, installed. Okay, let's come back here. Let's keep that on the side. Done. Perfect. All running remotely, guys. Yeah, Mac will be small.
It's all happening on the same thing, maybe, we just decided to do it first and now. Now it's coming together. I don't.
Yeah. The really cool part, right? We're all pretty much working on the same hardware now. Okay. Yeah. If it's installed, feel free to restart your kernel and run it. You should be able to reproduce this graph similar to this. It's a stochastic process, so it's going to be slightly different. But yeah. So right now I'm taking Intro to Applied Bayesian Statistics class. Yeah, Intro to Applied Bayesian Statistics, yeah. Biostats department. It's just 5 people in the class, so it's okay, I guess, but like, yeah. Yeah, one of the classes I think last term was taught by the author of the book that we follow itself. Yeah, it's okay. It's like no quizzes, homeworks. Most of it is just like based on your final project and presentation. But the only con is they're making us do like a 50-minute presentation next Friday.
50?
50 per person.
Every week.
Yeah,
Or professor, how many people in
Every
this
week?
class?
5 people over 3 days.
But did you learn much from that course?
Yeah, I'm gonna learn. If I need to speak for 50 minutes, I have to learn somehow.
Oh, okay, that's what it's going, it's doing right now. Now it's not that probably.
Great.
Well, I already did one.
That's why I was saying.
My students start.
Then I have to read the whole thing.
No.
But that's fine.
Dude, it's just adding a new sound. Oh, was it that? That's, no. Wait, hold on. I think this means that it's running.
Well, yeah.
Yeah, if there's something spinning, then it's running. Yeah.
Oh, yes. That's
On that probably.
yeah, I do think last year.
Not sure. So,
There's like last year, the whole page is more, I just
Okay.
for the previous one. I should go.
My computer seems to stop. It stopped.
Let me see.
Nothing moved. It doesn't bing.
Okay.
And yeah,
Of course it's bing.
pause maybe.
Oh.
Maybe like,
Have to wait.
yeah, maybe just wait a little bit.
Well, what about this one? Everyone else?
Oh yeah, I'm just trying to end the tutorial.
Yeah.
Okay. How long?
Sorry,
How long can we take?
I mean, technically, we had it at 3:15.
Okay.
And she's presenting at 3:30, so I want to make sure she has.
Gotcha. Yeah, of course. No worries. Do you guys want to shift outside? Yeah. It's good.
Oh,
Huh?
Heather's right there.
Yeah.
As soon as this is done.
Yeah, we have to end this up.
Yeah, I have to join the cloud computing class, so thank you.
I think for the presentation for Wednesday, it's not gonna be that much. Because we already have a plan, we already have a lot of our data. I don't think it'll
We need to
be
come up with like some,
slides.
yeah, model and like a risk management thing.
Yeah, but some ideas to hedge or whatever mitigate Okay.
Have yours finished?
Yeah, mine finished. Right.
Error that there's nothing to torch or something.
Oh, then then your PyTorch didn't install. Or did you reload the?
Yeah.
And then the thing itself it has to be test. The kernel has to be test.
Oh,
Yeah.
okay, that makes,
Oh.
okay. Yeah.
Okay.
Beautiful, I got it.
Oh, it's
So you
not
have
bad. I
Matplotlib,
just,
once you install Matplotlib, it'd be good one.
No, I think you just
Don't
restart
use
the
it.
kernel and then you
Oh,
can.
you're good.
I got the thing for me.
It worked.
Yeah.
And it says using GPU.
Oh, yeah,
First line.
mine says using
Yeah.
GPU.
Perfect. Yeah. If it says using GPU and the first few lines are running, then it's gonna probably work for you.
Great. I got you.
Perfect. All right,
Thank
let's
you.
move on to step 5.
Oh, I didn't realize this was
This is
the.
this is the last. This is the last thing. So if we want to send our jobs from the terminal without ever interacting with Jupyter, we want to be pro programmers. We're gonna use this framework or protocol, I guess, yeah, framework called SLURM, Simple Linux Utility for Resource Management. I'm just gonna read off of what I have here. It's a powerful workload manager and job scheduler designed for high performance computing clusters. It enables efficient resource allocation by managing compute nodes, CPUs, GPUs, memory, and job priorities across multiple users. In this tutorial, we'll focus on using SLURM to submit GPU jobs to Duke Compute Cluster. You'll learn how to create and submit job scripts, specifically resources like GPUs, CPUs, and memory. Okay, so let's take a look at the file. Is the file called test_CUDA slurm on your left?
Sorry, where will this be? And
Yeah.
yeah.
Absolutely.
oh, yeah.
You guys see the
Oh,
test?
maybe you can join Zoom so we can see your screen.
Sure, yeah.
So it should be test data.
Test_CUDA.slurm.
Ah, yes. Open.
Yeah, you can open it. Let's open it.
Yeah.
So this is how a Slurm file should look like, right? The first line you can just put there. The second line is the name of the job. You can define the name of the job. You can call it whatever you want. So after the equals to sign, in line 2, are you guys following?
Yeah.
Yeah. After the equals to sign is where the new name would go. Then you define an output file. See, test CUDA stays here. The percentage sign, I think, gets filled in by the job ID. So you can just leave a percentage here. So having the percentage sign basically will ensure that if you run the same job multiple times, every time you submit a job is going to have a different file name. So the old output is not going to get overwritten. So that's what the percentage sign here is doing. And then similarly, we have an error file. For the partition, we use courses GPU, just like how we selected in the GUI earlier for the Jupyter Lab. And then we are requesting 1 GPU in line 6. Line 7, we're requesting a number of cores. Here we're using only 4 cores. Line 8, we're requesting how much RAM that we need. Here we're only requesting 16 gigabytes. And max runtime, line 9, is the max runtime. So we're running this for 30 minutes. I don't know why I put max 2 hours here, but I think it can run for like hundreds of hours, if I'm not wrong. So line 12 to 16, here, you can just line 12, the 13, you can just put it there. But line 14 is of interest. So what we're doing is we're activating the Conda environment, right? So if we installed some packages that we need to run our code and test, or for example, if we install it in like a environment called tomorrow, right? We have to activate Conda, activate the name of the environment. And line 17 is where we're executing our Python script, right? So Python test.py. This Slurm, since we're running test.py, right? We have to make sure that the test.py script exists in the same directory as the SLURM file, right? So is it kind of clear on what we need to do if we were to run a different file using different RAM, different wall time, right? You'd be able to make those changes, right?
Yeah.
Pretty straightforward.
Yeah.
All right. And then this is just the test file. It's the same MNIST data set from the Jupyter notebook. But yeah, let's say we don't want to use Jupyter notebook. Another way we could run it is just like this. To the command line. So you could, in your terminal, you could copy 5.1 and paste it. So that takes you to the data directory.
Oh. Yes.
Okay. And then in that directory, I already created the test.py file for you guys. And I also created the SLURM file for you guys. But if you guys were doing this yourself, you guys would have to create these files yourselves, right? So we're just trying to run the SLURM file. And 5.4, we can copy that command. Yeah. And that submits the SLURM file to the cluster. And after that, you can copy 5.5 and replace your ID with RMR60, sorry, your net ID. And you should see all the jobs that are currently queued under your ID in the server. Right? It says I think you should see test CU_CUD as the name.
I also have a sys dash.
Yeah, that's the, I think, yeah, that's what we're currently using right now, right? Yeah. Either that or the Jupyter session that we have running, one or the other. So let's just keep on checking it until it gets assigned and we don't see that job anymore. Once that job disappears from this list, we know that our job has successfully run.
Oh, it's gone.
It's gone?
Yeah, so I already have
Perfect.
sys dash.
Okay. Now let's check the output of that file. So 5.6, copy 5.6 and replace that brackets with your job ID.
Do that.
Yeah. Nice.
The following, I just finished checking phase 2 and now going forward. This,
Oh,
but I
it's like
see
no such file
the same.
Yeah. So we're just trying to type the command until the first, this is the job that we submitted, right? Until this goes away. That's how we know that the job is finished running. As long as we see this test code, right? If I run it again, right? If I run it again, make it full screen. So if I run it again, we see that this job has been running for 29 seconds, right? If I run it again, we can see that it ran for 37 seconds. So just this command just checks what jobs you have active in your queue. So you can use this command to check if your job is still running. When it's finished running, this entry will be removed. And all you'll see is this line. So that's how we know that our job has finished running and our job ID is this. Yeah, yeah, it's still running on the back end, but this is just to monitor the status of your job.
But then,
Yeah.
So I ran for 5.6 and I did this test CUDA under the job ID that I had here. But then it's saying that no such file or directory.
The job ID is slightly different in my
Oh.
directory than it is.
Let's see, can you do ls-a?
Like, see, like,
Oh, is it gonna be this?
it's like this, but the ID is different.
But then won't it take this job ID?
But I don't know why the ID is different. Yeah, there's another one here. I don't know what
Let's
this
take
is.
this job ID instead of like page.
Good.
Does this mean mine has finished? The one line?
Yeah. Can you do ls-a?
Yeah, I don't know.
This one?
Correct, I agree. No, yeah, it's a totally different.
Yeah. Yeah, it should have been that number.
Yeah,
Unless,
that's the same that's happening with both of them.
Just,
yeah,
like,
because
has-
all of us are running it on the same directory. Yeah,
Oh,
yeah,
So y'all see mine.
yeah.
what is your number?
272444727.
727 is not here. I have 726 and I have 681.
same.
Same.
726. Yeah.
None of these are ours,
Is it
though.
because
Rookie
it's
is
still
only
waiting?
you.
But did the
It's
job
still
was
waiting. Because like, yeah, my thing is not showing up.
Oh, right, right. So we gave it a output directory, right, in the SLURM. So maybe it probably saved in that directory. It's probably not this
It's not
directory
this
itself.
one?
Yeah.
What do?
How do I get this?
Okay.
See.
Oh, it's gonna be in that slurm file, right?
Yeah.
Okay.
The
got it.
directory is saved in the
Okay.
SLURM file.
Okay,
In the
okay.
out,
Yeah. No.
It's very.
oh, it's not, it should just save it
Yeah.
in the exact same.
It should be
directory.
like test CUDA and then whatever job ID we have created, right?
Mhm.
Because that's what you've
Mhm.
Yeah.
done, the percentage J.
I don't see any directory here.
Yeah, it's not gonna be directly, my bad. Can I see your terminal again?
Yeah. So this is my job
Wait, do I
ID.
have to wait for this?
The-
Yes,
No, I
sir.
think you're good. You
I'm
have
good.
the
Some
one
of
thing,
these are from
but
now.
the
Some of
thing-
these are you guys.
but the thing is, I think you're running the same issue that we had. It's just-
See, my
One thing might be.
729.
Yeah.
But none of these are 729. This is somebody
Information.
else's. But I think it's
And
one of
it
you because
finished
it's happened
running,
to
right?
three- So one of you,
Because
guys- one of you should have 726.
we're just thinking about the time.
I don't
Oh,
know.
I have 751.
It's like, I think she can. But I thought she said.
And I have 726 as well. So okay, guys, I know what's happening here. I think you guys don't have permission to write into this directory
Oh,
because I made the data demo and data directory myself, and I probably didn't extend the like permissions to you guys.
here, let me check. I can check the permissions. Does this mean error?
No, that's where the errors would have been saved if your code had any errors.
So fast.
I think.
Your files didn't save here for some reason. So it should have ideally if you were to do does the permission thing match up? So my hypothesis is since I created this data directory, you guys don't have permission to write into this directory, right?
Yeah.
So
We only have read and execute. We don't have
Yeah.
write.
exactly. So when you're
So data, to look at it, is permissions. We asked our friend chat that says that this means that we have the owner has
Oh,
made
Monday,
permission,
yeah,
right,
Monday,
and
yeah.
execute, but us or group, we don't have any right. We only
yeah,
have
let me
read and
change. Let me try to
execute.
change the permission.
He said that. I said.
I don't think there's any of mine.
And Lila's like really ready. She's about it. She's a problem. Well, she's not all the time. No. About that one.
I think voting she actually is very organized and works hard.
Yeah.
And Professor screwed her over.
Why was I gonna do this with Kayla? I don't know.
So can those be?
Hello.
The classical.
Do you have class on Wednesdays?
No, I'm meeting with him.
Nice. Yeah. Look, you want to see my GPU graph?
Can you change the permissions again?
After I do Sean.
Okay.
Now I have to look at the permissions.
I tried to change it.
It changed.
Yeah, it was.
Where do you see that?
Doesn't mean. Yeah, no, not the job, but the clock, that was still through the.
That's.
Oh, yeah, the
It's
permissions
just
are
like
different
the
now.
terminal.
Oh, different now?
I think
Okay.
that should work.
Yeah, so if you guys run it
I-
now again, it should work. I changed the permission
So
of that
we do
directory. Yeah. Huh?
Hey, I think our things might just show up. Start from 5.1.
Oh,
5.5.
Which was step to which
Uh,
restart.
5.4.
5.4. Yeah.
okay, my job's not.
So.
So wait, be patient.
Yeah, this should work.
Twice.
Patience is a virtue.
Why do you
This is why it's so important to run through these things with other accounts.
I got solid again. No, I was gonna, but then Diego seemed to have like a very intense call, so I was like, I'm not doing it. Notice passport. I don't know that. I wish I did not know that.
But I did use it this morning at least.
No, yesterday it was her. I think it was yesterday. Yeah, I did.
It didn't taste that gross this morning.
Like I felt like a shawarma. The coffee from Ross is not raw.
I tried eggs.
Oh, this is good too.
Ha ha ha.
So this job here, if you run it again, if it goes, then you can go with 5.6. So that's basically this, the 5.5 command is basically monitoring where your job is. Yeah.
Mine's on 1.
Mine's done, I think. No, why did I do it again?
Wait, what happened?
I did something fun.
Yeah, see, when I entered that like next thing, the test output,
Oh yeah.
like, the output, I don't get it.
Oh, are we supposed to wait for one of them to disappear?
Yeah.
Yes.
So in 5.5, when you do SQ-U, how many entries do you see there?
I thought 1, and then now it became 2.
Yeah. So you have to, so the second one, right? The one that says name test could is your job. You have to wait for that to vanish.
Oh, I see. Okay.
Those are on the
Resource,
test.
because like that is a node list reason versus it means it hasn't been used.
Yeah, it hasn't been assigned
Oh, GPU.
GPU. When it's assigned, it's gonna say something like DCC courses GPU 1, GPU 2, GPU 4.
It's still running with 2 of my jobs because I
I
did
don't
it
even
again.
think it's running. I think it's just cute. Like once theirs is
Oh,
done,
yeah.
then ours is.
Yeah.
I think it's just cute.
No, oh.
If it's running, then you'll see the exact resource it's running on plus a time.
But is your guys' times for test based 0?
Yeah. Just see, 55 and 120.
Perfect.
Mine is
Okay.
still 0.
So-
Oh, one go
but
down.
It could be because it's still being
Okay.
cute.
Yep.
Because all of us.
Got
Oh, do you have to keep running the queue?
Yeah.
You
No,
just
no,
want
you
to,
don't,
you
you
want to
don't.
keep, you don't
If you want
have
to monitor.
Yeah, I was.
You got it? The cat worked?
Yeah.
Perfect. With your job ID, right?
The aim of them.
Perfect.
Oh,
2-7.
Yeah, so the output goes in the output file, and if your job had any errors, then that would go in the error file. Perfect. Yeah, there you go. You have to save it in your script. Whatever you do in your script is gonna happen. So if you save your model, right? In a pickle file, for example, right? You'd have to do it in code. Like, okay, after training this, put all of this text output in the output file.
exactly.
Sorry, everything that would go in the
Yeah.
everything that would go into the standard terminal, right? Everything that you would print will go to the output file, but for saving a model, you'd have to specifically, with purpose, save it in the code, right? So once the model is trained, dump it to a pickle file or something, and then it's just gonna dump it in that directory. Yeah. Yeah.
Yeah. See, it also says over here at the bottom, finished training, accuracy of the network. So if you're able to see those, I think.
The first line should say GPU used.
Yeah,
Using
using
GPU.
Yep.
Yeah. Yeah, so that basically covers what I had for today. One example of utilizing GPU from Jupyter Lab, one example of doing it through SLURM. And then I just have to like wanted to show you guys one other example of like where you might need GPUs, right? So I don't know if you guys went over Hugging Face in any of your classes
Yeah.
yet, but yeah, a lot of like the models, open source models that are out there are hosted on Hugging Face. Google has some models, Meta has some models. You can post some models if you want, right? So here, like suppose you want to take like a small language model, a BERT is a very popular one, that's been pre-trained for you using like so much resources, but you want to use it for a specific task. Maybe the model was made to analyze sentiments of like everything in the world, and maybe you have like 1,000, 2,000 examples of sentiments in like finance specifically. Then what you could do is like just go to like huggingface.com. There's an example of how to fine tune all of their models.
Sure.
You could fine tune those models from Hugging Face as well. There's instructions. It's most likely gonna use PyTorch. It is gonna use PyTorch. So when you install PyTorch in the environment that you want to fine tune this model in, make sure to install the CUDA version of PyTorch, right? So this is just one other example of where you would need where you would need GPUs, right? Fine tuning models, yeah.
We used SLURM with a Python file here, right?
Yeah.
But can we also do it with like a Python notebook or no? It has to be with a Python script.
You can do it with anything, right? The
Okay.
slurm, the last command that runs the Python script, right? Is just a command. Imagine you're running it on a terminal.
Sure.
So any command that would run on a terminal, if you put it there, it's gonna run.
Okay.
Yeah.
We should ask.
Okay.
I have a question. Mine has finished running, but will not have.
If it has the
there
permissions,
is
it will
issues.
Can you just give us the permissions? We should also be able to do it.
Yeah, because this is the job ID, right?
Yes.
277248111. You didn't type that here, right? So if you do
Oh, I thought I need to use my net ID. Sorry, I'm so stupid.
no, okay. No worries.
Yeah,
You got it?
yeah,
Perfect. And then the first line says using GPU.
yeah.
Perfect, yeah. Good job. Hopefully the next time you guys encounter a HPC is gonna be easier to figure out.
Yeah, so changed.
Very well.
Thank
Very
you.
helpful, thank you.
Of course.
So you said like.
Yeah.
Today's stuff, you said if we want to remove it, we should do that kind of thing. Like, well, how do we do that?
Huh? Oh, right. So if you wanted to remove mini conda, right?
Or do we have to, Minicon or?
You can free up space.
Yeah, if you want to remove, yeah, I think you have to do that because like otherwise it wants to save like a lot of data into the directory that you installed it in, right?
Yeah,
Since it only has 25 gigabytes.
right.
Don't, I guess like if you're just using PyTorch, right? The environment that you made today is probably going to be good enough, right? Probably not going to need too many other libraries, right? So
Yeah.
if you use something like if you use Hugging Face, for example, then I'd recommend to completely start from scratch and make this miniconda in like the courses partition, right? But if you're using something that uses PyTorch only, then like the thing that we did fine is today is fine.
Okay,
And because the courses partition is still, we're doing it in our environment, nobody else would get those benefits. It would just be,
Yeah. Wait,
Makes
hold on. No.
no,
Everyone has access to anything that you do in courses partition.
okay.
Yeah, but like just like how I had to give you permission to write into a directory that I created, you have the same thing as well. So any directory that you create, you're the only person who's gonna have execution access, I think.
Got
Is
it.
how I think it works based on what just happened. Okay. Yeah, anyone else have any other questions?
So like suppose like me and Rutha both try
Yeah.
and download Miniconda in the courses directory. But then like if I downloaded second, then I
Oh,
overwrite
right.
hers.
So when you're downloading Miniconda in the courses directory, make sure you make a subfolder
Uh-huh.
and then make that and make Miniconda there. I think Kyle has a subdirectory in the courses and he installs Miniconda there. So you can use that as a guide. Like,
So if you download it in the subdirectories,
Yeah.
will it still be accessible through the data directory?
yeah, it's still gonna be accessible. Yeah.
Okay, okay.
What else?
Well, we don't have questions. I got it. Someone
I
got
think
it.
it's morning, you should be asking questions.
Should I be asking questions?
You should be asking questions. Mhm.
Update.
Oh, and then try to make your directories inside the IDS 705 directory to keep things more concise because it seems like every course is using their own directory. So like we don't want to mess up other people's work.
So
So
IDS
inside
705
IDS,
storage.
yeah, inside IDS 705 storage, there's another directory called IDS 705. And in that, we can see a directory called KG,
Yeah.
KJB17. That's probably cow, I'm guessing. And inside that directory, we can see that Kyle installed Miniconda. So you can use that for kind of structure as base.
Oh, I see. We create our team.
You wanna,
Yeah.
you can do the honors.
Sure.
Huh?
Says permission given.
In IDS 705?
Yeah.
Yeah, he has his Miniconda too.
Okay, then let's just create another directory called IDS 705 new.
Project.
Um, I
Or
can
string.
ask Carl to grant everyone access. That's probably the easier thing to do.
Like I'm in IDS 705 storage demo data, so I just do CD. Here?
Yeah, you can just do CD quickly, right? That's gonna take you to your home directory.
Oh, okay. Yeah, I'm here,
And
okay.
then let's see ls, and then go into this IDS 705 storage. And then course 25.
You can check the area. Yeah, I mean.
Oh, sorry, was it that? Oh, right. This is the directory.
So we're
Yeah.
making, so.
IDS 05 705 is the directory that Kyle made, right? But unfortunately, we don't have access to write that.
Yeah, Atraya, can you update the permissions for so
chmod, the command to update
Oh, I see it.
the permission is chmod hyphen capital R 777 and then the name of the folder.
Is this in the terminal?
Yeah, in the terminal.
Okay, sorry. Could you repeat that?
chmod
PH.
hyphen big R
Okay.
777. So this is like gives everyone every permission.
And this has to be still within the IDS 75, right?
Yeah, the directory. So just go one directory back,
like
right?
Okay. I
the
think
storage
it's
one?
Yeah.
DB.
CD
Got
dot.
it.
And then
No, it's. I think I might need to re-log into the connection lost because it says send.
You just have
send
to be-
disconnect connection reset after I did my thing. So I'm just gonna
okay.
do this from sorry. In a second.
The chmod command should let you do that.
I just see take koala. And
Yeah.
yeah, thank you.
Well, you might also need like permissions to be able to
Yeah.
Yeah, that's me.
do anything in the folder.
The folder's up there, I'm happy. Yeah. Just doesn't want to cooperate. He's not getting the output law.